Okay, yeah, I think it's time to start. Yeah, it's 10:02. So good morning, good afternoon, good evening. It's lesson 4 of the machine learning. I hope there's still more people going to join. We just posted link on the Slack. So lesson 4, I think there was a busy lesson. I think a lot of content in that lesson. So we are the feature importance. How do I put this? Feature importance in the tree interpreter. That lesson is also on kernels if anyone wants to run it. Otherwise, I'm pretty sure we have already some other ways to run the code.
Was the PDB issue solved? You were facing a problem with the plots.
Yeah, there was an issue in a code that was not printing the PDP graphs, but the latest update from on GitHub repo fixes the issue. So I just updated this morning and put that change on a kernel as well, and hopefully that finished saving. Let me see. Yeah, the version 4 is now saved. So if you wanted to run that lesson on kernels, it now prints the nice graphs. These are the ones that previously was not printing, so it now works. So yeah, please feel free to use those, as kernels is free to use. Okay, where are we? Come on, where is my notebook here? It is here. Okay. So yeah, so just a quick overview. I'm using all the pictures. I mostly put some pictures in the presentation are from that lesson notes. So if you click here, there is very nice lesson notes, and there are notes for every lesson from 1 to 12. And this describes in detail basically everything Jeremy said, and then it's all nice pictures. So I took all the pictures from, not all of them, some pictures I thought key pictures from there and put in a presentation just to quickly go through that today. So he started talking about, started the lesson talking about the size of a tree and how the set RF samples work, and the like the log of the base of 2 and then number of samples. That's how deep is your tree if you don't use any other hyperparameters, and also how many nodes are in the tree is basically the number of your samples, in this case 20,000. Yeah, once you start implementing like hyperparameters, like what was it, the max features and then minimum number of data points in one node, then that of course would change. But as a basic, this is how big is a tree. That's in relation to the last lesson. And then he started about the feature importance. So once we have our model, our random forest, how do we know which features are the most important? So he's using the Fast.ai library for that. And with that graph, we can see that in this case, the year made is the most important. And then the rest follows. So I think that's a very interesting graph to, especially like he explains in a business situation, if you want to explain not that only you can predict, for example, in this case, a sale, but also if you can say which features is the most important one. So then he starts with this graph, but then there's plenty more. So once he can see that some of the features are not really that important at all, he decided to remove those. So like the those here that are below a certain threshold, and he didn't use any certain value as such. To what I understood, he just look at the graph and say, I'm not going to include those in my model. There is some background noise. I will try to mute my guys. So manage participants, mute all. So if you want to talk, just unmute yourself. Okay. Yeah, so then he decided to remove some of the least important features, and that's the more simplified model that still is very good predicting the on our output. So that's always better to have less complex model. Go to next slide if I can. Right, and this is another technique that he showed that could be used for further reducing the model. So this is like how to find variables that are like related to each other. So in a linear situation, that will be called collinearity, but because here our model not necessarily linear, so it's not necessarily collinearity, but kind of like those variables that potentially don't add that much, because so we can remove one of them. So if two of them show the same input, show the same relationship to the output, then we could remove one of those, and then again our model is even less simple. So he used this nice tool which is called hierarchical clustering, and then with some Fast.ai code and some additional code, he was able to find out so all those variables that show this connection very early on from the right side. He says those are related. So potentially we could try to removing, say in this case, the sale year and the sale elapsed. We could try to remove one of those variables and still our model will be as good as it was before. So that's what he did. And he was using the Python code. I'm not sure if that was Fast.ai library or not. And he was removing one at a time. And then he was checking whether the R² value is still good. And he checked all of them one by one. And then basically he decided that the R² was still very good. So then he removed, and then you can choose which one you want to keep, which one to remove from each pair. And then he even simplified that model further. So the goal was to still keep the good prediction R² value, but the simpler the model, the better. So that was another good tool. And then he started using some ggplot graphs. So this is the R graphs ported to Python to find out, to further show, like in a business situation, what does that mean on each, on those, the most important variables, how do they relate to the sale price in this case? And then from this graph, if we just print the year made and the sale price, it looks like the price was going up throughout the years, and then was like a dip around 1997-ish, and then it was going up again. So that's kind of like, according to Jeremy, doesn't tell the full story about the price. Therefore, this PDP plots.
About that one there, I'm surprised that he wouldn't have inflation, because I think there would be a strong correlation between that and inflation.
Yeah, as a feature engineer, right? Yeah. Interesting point. Yeah, indeed. Yeah. So this kind of like, so I think this graph, that's the way he was explaining it. So once you so the way you create this plot is quite interesting one. So you replace, like in this case, the year made column, which with the each year that's it's under investigation. So I think he started like 1960 or something like that. And then, so instead of removing a column as we did, or like shuffling that column as we did in the previous feature importance exercises, in this case, we fix one column into particular year, and then we see how that would affect the price, and that he does that for every year up to 2008 or something. And in this case, we see on average, because the yellow-blue line is the average, and looks like there is no that dip anymore, as we've seen on this graph. So it shows that indeed, on average, the sale price would go up, which would suggest inflation. That's what also Jeremy mentioned. So I think that's an interesting graph. I didn't see that one before. This is similar graph, but just using clusters instead of having all individual, because he used 500 data points for the graph, all those the blue lines. This one, he just used clustering. So instead of all of them, we can see like clusters of similar looking data points.
Which kind of plot is he using there?
Yeah, so this is from this PDP library, partial dependence plot, I think that's what it is. So you have to import that library, PDP. If you look at the code, it's here. So in the kernels, I believe I had to import that one, or maybe not. Let me see. Or maybe that one was, but the other one, the scikit miscellaneous, that one I had to import. It wasn't there, but I think the PD plot was there. So this is the, yeah. So he also defined that function plot PDP, which was using the PDP library. So this is part of the code that he's using to generate those nice graphs. Yeah. Yeah.
Also, someone has mentioned in the chat that the reason that how random forests work with random selection of subset, they don't expect much improvement after removing correlated variables, because random forests, they usually select a random subset.
Mm-hmm.
I think that makes sense.
So you're saying that if you have the subset, right, like the set RF samples, right?
No, someone has mentioned on the chat that
Okay.
random forests, they randomly select a subset, right? So they don't expect much improvement after removing the correlated variables.
But it would still help in interpretability. So if you have less number of, let's say, sample features, then it would be more, let's say, you can decipher the meaning of that thing. So if in the business implication kind of thing, I have seen thousands of variable and then you don't know which variable to look for. So by this way, you can most probably narrow down number of variables. Your model, let's say, performance is still reasonably good, and then you can most probably meaningfully figure out the meaning of the feature. So if you want to go back to the feature, it might help.
Yeah, that's a good point. But my point was that because of the way random forest works, where it chooses a random subset of the features for each split, so that it doesn't always use all the features. That means that over an ensemble of trees, it will have trees that only have one of those if there are two correlated variables. Many times it will only have one of them, and so you won't get this kind of confusion because of the correlation. So that's all I'm saying is I don't expect that the model is going to get any better if you eliminate the correlated variables.
Yeah. Model will not get better.
I don't think the accuracy is going to get any better with removing any of the the variables. Yeah, but the speed of the model should be better once you take off some of the features that don't improve the model.
Yeah, that's true. That's a good point. And it's also simpler. The model becomes simpler, so that's another advantage.
Exactly. So that kind of goes into the interpretability side of things in a business sense.
Mm-hmm.
Yes.
Yeah, I fully agree. I'm just looking for the numbers indeed. So once he dropped those additional variables, he got 0.88, but I don't know what I was before. I would need to go, but I don't, yeah. That was 889, so it's a little bit lower, but not that much. But I agree, the model is much easier to interpret, and also you can compute faster without less with less. Yeah, good point. Yeah. Yeah, so the last slide, I think, what I have, not one before last, is this is also a nice graph. It shows the interaction between variables, and in this case, it's year made and sale elapsed. So we can see that if sale elapsed, what is it, goes up or down? I don't see from the graph anymore. From 1,000 to 8,000. So if that increases, and then at the same time we have, yeah, so the thing with the interaction is that if you just look at the individual graphs on a year made and sale elapsed, you will not see the whole picture because there is also interaction between those two variables. So that's what interaction is. And with those graphs, you can see that. So if you want to go for the highest sale price, that's the yellow one, you would want to have year made as high as possible, and also the sale elapsed as low as possible. That's what I can see. Yeah. So that's a cool graph, I think. That's also a thing from PDP, if I'm not mistaken. And this one's pretty much showing similar thing. No, this one's PDP. The other one was different, I think. This graph shows similar situation, but there's different graph. Right, and also he showed the how to interpret the tree. I think he started that at the end of the lesson. He didn't finish that one. So basically, once you have all your tree, you can also see how each, by adding and taking average of those changes. So like if you look at all your trees and see how your how that split affected the your value, your mean, then you can add those up, and then you can see whether that particular variable has got positive or negative effect on your prediction, and also of the magnitude of that effect of that variable. So I think that's also quite cool feature.
Michael, how did he define enclosure? That I didn't get that. That doesn't make any sense for me.
You mean when he started to split an enclosure into different, the kind of one-hot encoding part?
Yes.
Yeah, let's well look into, maybe if you go to this one, right? So indeed, there is a point when he goes into one-hot encoding, if that's the question. Where was it? Right. Yeah. So because the enclosure had different type of enclosures, right? And what does it say? It was like 4 or 5 different types of enclosures. So normally random forest would kind of like treat that variable as a cardinality of 4 or 5, whatever that was, and try to figure out those splits. But there's another way, and sometimes it works better when you, I don't see any nice picture of that, but you can create, so instead of just having one variable of that enclosure, he creates that many variables, as many as the level of cardinality of that variable is. So if, say, enclosure was A, B, and C, he would split that into enclosure A, enclosure B, and enclosure C, and then he would put either 0 or 1 in that column, depends of which enclosure was used for that particular row. And in this situation, he said he can also look more closely into if the enclosure, and especially which enclosure has got the most effect on our output. And that was the case in this situation. On that graph, we can see that enclosure aerobes with air conditioning, with AC, is got the highest effect, even higher effect than the year made, than the previously highest variable. So I think his point was that sometimes it's, of course, maybe you don't want to do that for every categorical variable, but in this case, he did that for enclosure, and he was able to find out which type of enclosure has got the highest effect on the sale price. That was my understanding. If anyone wants to add to that or got any more comments.
I think my understanding of that particular graph was how does the sale price differ with respect to 3 different types of enclosures. For example, the one which is at 0 in that graph is the one with an AC, right? So usually that commands a higher price, and the other 2s are ones which are slightly lesser in terms of their category, and therefore they are varying from the price downwards, and that's what that particular graph shows. That's my understanding.
Mm-hmm. Yeah. Thank you. Yeah, I think. Yeah, and I don't have any more slides. This is a quick summary of what I've run into in this presentation. I think it was a lot in this lecture. And it's basically just Q&A now, I guess, about what learning was most interesting for you, what sort of maybe stumbling blocks you ran into. Was there anything in particular you did on a homework? Any resources that you found interesting? Just general discussion over the lesson. So like some of you also attended yesterday's deep learning session. So some of us had a bit less time than usually to experiment with that lesson. I was in that camp as well. So I was only able to run the code in a lesson. I was not really able to implement that in any other data set or on that Kaggle taxi competition. You guys run any projects, any side projects? Anyone did that taxi fair Kaggle competition or any other competition you want to share?
I'm trying the PUBG one, but I haven't gotten far yet, probably by the next meetup. But it's pretty interesting. It's worth a try, I would suggest.
Which one?
PUBG one.
Is that on Kaggle?
Yes. It's a playground competition. I'll share the link.
It's PUBG competition, I guess.
Yeah.
So, mm-hmm.
Yeah, there's a couple of people that's also working on the 2 Sigma financial modeling competition on Kaggle, specifically for the deep learning section. So we're that one.
Yeah, that's the one.
Yeah, we're working through that right now.
And you're using the deep learning neural network on that, or? Yeah.
I haven't. Yeah, I don't think we're trying the any of the steps from the machine learning course, but yeah, we'll see how we do on the deep learning side.
You want to tell anything about this competition a little bit? So what it is and.
Not yet.
Okay.
I mean, probably next week I might have a little bit more results to share.
Yeah. So it is about predicting the stock price, right?
Yes.
Based on using news, right? Okay.
Yeah.
What sort of data they give you? Let's have a look.
There's like market data. But we're talking about like feature engineering for incorporating some NLP and stuff too. But
okay, wow, nice.
Yeah. So yeah, it's a pretty big undertaking, I think. But we'll see how the results turn out.
Very good. Yeah, we'll be interested to hear about this.
I'm trying to quick draw a doodle recognition challenge for the deep learning one.
Okay.
But it's basically I'm using CNNs over there. So it's not related to machine learning, but it's another it's another interesting competition, I would say.
Yeah. So I was looking into that. You get those pictures. It's like I think you get. So my daughter was playing with that the other day. I saw this quick draw. You have like 20 seconds to draw something.
Yeah.
So it tells you, it tells you to draw something and gives you 20 seconds. And then, oh, I have to draw a moon. Okay. And then in that, it kind of tells you, yeah, and then it says it was moon. So then it's using, I think in the competition, we get all those like pictures that people draw.
Yes.
So it's like 50 million of pictures. So there's a lot of noise because now I have to draw a piano and I can draw, I don't know, just square. Yeah, it says it's a square. And then, I don't know, so then I don't know if that square now ends up in that data set as piano. It could be. So then I think the
that's
point
the challenge. Even after classifying, like when I was trying to interpret the results, I could see the noise in there. So I think that's part of the challenge as well.
Yeah, I think that's the part of the challenge because you get a lot of noise. And so how you make your model work in presence of all that noise, I think that's the challenge here. So that's an interesting one. Yeah. Yeah, that's
Some
cool.
people are trying RNNs for it and they think it has better results, but I'm giving CNNs a shot.
Nice. Yeah, indeed, because they give you the data they give you, it's not pictures as such. The data they give you is just the
CSV file.
Yeah, it's a CSV files with numbers. So you could use RNNs. I agree. Yeah, it's a nice one. Yeah, there's a lot of competitions at Kaggle, but in terms of like the machine learning, I think there's more and more of image recognition as such.
Just the playground PUBG one, I think that would be worth for machine learning. Otherwise, it's mainly images dominantly.
Which one that was? PGP you said?
PUBG, this last one. Just the one above NYC. No, scroll up.
Oh, this one. Mm-hmm. Okay.
Yeah.
Okay. And can you know about this competition a little bit? Can you?
Not a lot. I mean, I play the game a lot. It's based on the game, so that's what's interesting to me.
Okay.
But it's like they give you some data about the game, and you have to make predictions about the player's positioning using that.
Okay. Nice. So they give you 65,000 games worth of anonymized data, and they give you training and testing set, and they ask you to predict the final placement from final in game, right?
Yeah, in my school, it's one of the most famous games, so that's what's interesting to me.
Right, yeah. So they give you like a lot of different columns to figure out. So you're thinking of using random forest on that? Or
yeah, I'm trying to give it a shot, but I don't have much to show right now. Probably by the next meetup.
Yeah. So there's always this thing with Kaggle, the kernels. There's a lot of already done kernels.
Yeah.
So it's a good place to start. A lot of people give like, they even talk about games, and then they show you how to import the data, and they would also plot already some graphs. So it's a good place to start sometimes.
Yeah, I can always find many great ideas in there. So
yeah, I sometimes like, oh, I want to do it myself, but then never have time, and then I just look what I did, and yeah, this guy did a good job in visualizing the all the data. Okay, cool. So we could look at that. So the last time we had taxi competition. So if anyone still doing that and wants to present today or next week or anytime, we could also do this one. It's a good one, I think.
Or any other competition at all.
Yeah, or any other project, side project, and I think that's the best way to learn.
Is anyone else working on any other competition or?
Is anyone using those techniques in a work?
Well, like, I'm not doing any kind of competition in Kaggle, but I have a final year project going on. So it's based on lung cancer detection. It's based on like image processing, CT scan images of patients, and then predicting stages of lung cancer.
Yeah.
So it's kind of a bit challenging.
Interesting. So you have your input, the training data, right? Which are classified by some physicians, doctors, right? I guess.
What data are you using?
I'm using CT scan data of patients. I got it from cancer. There's a cancer archive online, which has lots of data about lung cancer, liver, neurons. So there I got some 50,000 images, CT scan data.
Okay.
So we'll be
Wow.
that
Interesting.
to predict, like, so, yeah.
So yeah, that's a nice one. I think there's also similar Kaggle competition now, which is almost closing.
Yeah, so I had a look at it. It was also lung cancer one, but
it's on pneumonia. It's also where is it? This one, right? Is the pneumonia, or is a different one? So this one gives you also a lot of images of some cases. Yeah, that's right.
This one also has many interesting kernels if you want to give it a look.
Yeah.
Yeah, they are using actually X-ray images, I guess, and we wanted to have some CT scans.
Okay.
Like I'm using some
CT scans are more. Yeah. So the CT. Yeah, nice. So the CT scans you have are 3D images or just 2D?
They are all 2D images. Like they are the whole scan of whole scan of a patient's body from head to toe.
Yeah.
So firstly, we need to determine those lungs. I mean,
because you can like because that scan you can just like slice, to what I understand, the CT scans, right? You can take different slices. So if they scan like over like 30 centimeters, you can take any part of that 30 centimeters like a slice.
Yeah,
you
like
have to choose.
Input data. Yeah, like input data can use whole of the images, but we only need to have those images having those lungs and those tumors.
So are you trying to make a bounding box thing or just predict the probability?
No, like we're using some image processing techniques. I guess marker line watershed algorithm and something like those. So they will be.
Are you trying to predict the location of the tumor or just the probability of the patient having cancer or not?
No, like we'll be firstly searching for if a patient has tumor or not, like negative, positive images. Then if a person has a tumor, then we'll detect which size it is. So based on that size, it will give which stage he is in, like stage 1, stage 2, or stage 3.
That's interesting.
Yeah, so that's really cool.
In this this tumor detection thing, what is your image size or what is your data size?
Like if you talk about, I have 50,000 images.
One image.
Okay, one image is, I guess 2 to 3 MB, I guess.
No, the dimension of the metric, pixel wise.
Okay, I've not gone into that detail.
So why I was asking that was like maybe you would like to localize that thing to the part where you might have higher probability of finding the tumor. So most probably, because you said you had a CT scan from head to toe, and if you are concerned about the lung cancer, most probably you want to have localization on the lung and then try to detect the cancer like tissue, like cells. That would be, let's say, more easy, I think.
Yeah, like I referenced some research. So they said that lungs basically in CT scan are totally black. So we can identify from whole of the CT scan that what is the lung part. And if I go to further images, then I can see those kidneys and livers. So I know that what all images I want and what all are not. So I can basically, I have to like make another data set. So it will be a bit like you are saying. I would give it a try.
No, I was just discussing that. Yeah, maybe that is one more approach. Yeah. Nice.
Yeah, very interesting. So there is yeah, of course, a lot of interesting deep learning topics.
Do we have this recording will go to YouTube, or for example, yesterday's DL study group meetup I couldn't attend. So can I have have a look somewhere?
Yeah, so Sam Charrington, he usually would post that one on YouTube, his channel. So there's a TWiML channel on YouTube and also on the TWiML site. So yeah, he mentioned on a Slack, he just mentioned on a Slack that he will do that shortly. Let's see what he said exactly.
Just after 3-4 days, usually, I guess. They do some production edits and all.
Yeah, he said soon. So we'll just keep checking wherever he does it. But yeah. Yeah, yesterday was interesting session. So we just, for those who didn't attend yesterday, we just started first lecture again, like a restart of the deep learning course from Fast.ai. And the reason for that was because Fast.ai just started the new version of the course they call version 3, which uses the new version of the library, Fast.ai library, which is version 1. So, and they opened that for also remote participants, and they call it Fast.ai Live. So you can watch videos as a live stream from San Francisco. So it depends where you are. That's for some people like in the middle of the night, and some people did watch it as well. So that's, yeah, I think that was really good. The first lesson was really good. And
yeah, if you're interested, you can come hang out with us on the Slack. It was fun.
Yeah. So what I saw, like for anyone who did the deep learning part V2, the previous part, this one is a little bit different. So it's not only the library is different, but they also changed examples. So like instead of just dogs and cats as they did last time, which is only 2 categories, either a dog or a cat, now they have multi-categorical data set. They have like 37 breeds of dogs and cats, and that makes it a little bit different. And the lecture 2, which already appeared on a GitHub, shows that the next lecture is about
image segmentation.
Right, yes, image segmentation. So that looks interesting. So that's deep learning. So we have 2 sessions. So on Saturdays at 9 that's 9 Pacific time, we have deep learning, which we just started, and on Sundays, which is this session, we have machine learning, and that's at 7 Pacific. So, and we are lesson 4, and this is 12 lesson in total. So there's still a couple of lessons to do for random forests, and then they switch to neural networks. Yeah. Anything else from anyone? Any interesting resources regarding machine learning or deep learning, or any other questions?
Michael, I wanted to ask a question yesterday. You see, one of my concerns with the Fast.ai course is that, you know, I think the code base has been changed from 0.7 to 1.0. Do you have any thoughts on that or any more information on that? I think the entire library has been rewritten. So, you know, what really happens is that in production environments, you know, if we need to use it in the future, is there any guarantee that the next version of the course would have a completely different library?
Yeah.
Any thoughts, any ideas?
Good question, because the change from 0.7 to 1.0 caused a lot of confusion everywhere.
Yes, yes.
They're breaking
Yeah.
updates very soon, but now they stopped.
Because
Yeah,
I
so
think, no, there are two parts. One is the learning from the conceptual point of view, and the other is the learning from the code point of view. So I think what I personally gained from the course, the first part was the concepts. Certain concepts that we picked up were very really useful.
yeah,
But when you start implementing it in code, then you need to, for example, one of Microsoft's successes has been that, as and when they've evolved their libraries, they've made sure that, the earlier versions of the software have still been compatible.
yeah.
So I don't know whether this has been discussed or because unfortunately for me, the Saturday timing doesn't suit me. So I can't join the, group on Saturdays. That's why.
Yeah, yeah, it's a valid point, and seems like it's incompatible at all. It doesn't work. So all
Yeah,
the
there's no backward
yeah,
compatibility.
yeah, all the platforms, like when you can do the course, they've created a platform to work with Fast.ai 1.0, like the Kaggle kernels. That was a big kind of mess. They've moved to 1.0 once, and then it was working, and they moved back to 0.7. So now 0.7 works, 0.1 doesn't work. That's a good point, but yeah, that wasn't discussed. But hopefully they will stick to that for now,
No,
because
I guess because I haven't raised the issue. I try to follow the forums
yeah,
because I think this version is based on PyTorch 1.0 and I think the earlier version was PyTorch. It's an older version.
yeah,
So when
that's
the
right.
base library itself changes, then you obviously will have changes at the upper layers.
Yeah,
So let's hope because otherwise what really happens is it's good as a learning environment, but once you start let's say if you want to talk of putting it into production, you really need a stable foundation, both at the PyTorch layer as well as the higher layers, Fast.ai layers.
yeah,
Because I think one of the driving motivations of Jeremy has been to beat the latest benchmarks. He always looks at beating world class benchmarks, and he's doing a remarkable job as far as I can see. Beating companies like Google and Amazon and Facebook. But you need to make sure that the earlier versions of the earlier code libraries are also are consistent with what has been taught in the past.
yeah, I fully agree.
I
So
think
let's
my
hope.
understanding is that since there was no documentation earlier, or there was a few buggy functions, they didn't support backward compatibility. But hopefully now it's a much more streamlined thing. So probably they'll provide it.
Yes, I hope so. In fact, Kai also tried to create documentation, but I believe since they've now moved completely to notebooks,
Yeah,
and
Yeah.
because see, ideally one would like to learn both. One would like to learn the concepts also as well as learn the code also, so that you can build your own modules and your own libraries on top of it that you can use in
Yeah.
the future.
If you want to look at the development phase, the dev notebooks, you could essentially replicate the library by going through them. But I agree with your point about the production environment.
Well, actually, I have not worked with PyTorch in the past, so obviously I have worked with Python, but I just thought if one could, if any, maybe
If
I'll
you
ask that question. Yeah, sorry.
No, go ahead.
No, maybe as the course progresses, there will be some clarity in terms of. And just somebody had asked the question on, I think on a Slack forum only. Have they published a schedule of the deep learning course? What kind of lectures? What will be covered? Any idea? Any thoughts on those?
The
Like you
syllabus
mentioned,
isn't
image
mentioned, but
segmentation, right? As the
yeah,
next lecture.
we found out on the GitHub, but there's no mention of the portions being covered. They said it will be covered in the next lecture.
Okay.
yeah. So
And in general,
I can only guess, looking at the docs, this page, that they still have vision, text, the tabular, and the collaboration, the collab. So seems the same kind of scope as last time. But whether they're going to include all of that in the course, yeah, we're only going to see. He didn't mention this time what he's going to cover.
Okay.
No,
I guess
from what it was before. So if you see, there was something called structured before that is entirely not available in this new 1.0 library. And from my point of view, the way I look at it is, suppose if you had TensorFlow, and you started with 1.2, today it's now 1.8 or 1.9. You still have the option of going back to 1.2 and doing what you want to do in 1.2. And if you're now comfortable with the 1.8 version, choose that and do what you want to do with that. Fast.ai will remain the same. Every year they will move to the cutting edge. And if that means that, following what PyTorch is following, since they are now based on PyTorch, then that will be the case. Backward compatibility, probably with their bandwidth, will not be too much forthcoming and supported, because they are also not having any business model. If you look at what Jeremy has been saying, this is purely from a educational point of view that he's doing it. So I really don't foresee that support coming so soon.
I think the remarkable part is that PyTorch 1 in itself is in a preview version right now, and still it's built on top of that. So I can expect breaking changes just because of that fact.
And in fact,
sorry, go ahead.
Yeah, and in fact, like for example, if we look at TensorFlow, it is very stable now after, let's say, at least 4 or 5 years. So that kind of stability only come with time, and like once people start using and all those things. And Fast.ai is relatively new in that term. If you think in terms of years, it has, let's say, been developed and then being used. So yeah, like I think it would take still 1-2 years to, if they want to have it in a version, a stable production ready kind of thing. So yeah.
Even
I have a
Facebook's
couple of sorry, go ahead. Somebody else was saying.
Yeah, even Facebook's point about PyTorch is that it wasn't production ready, and that's what the promise of PyTorch 1.0 is all about.
Okay.
So if you follow the release notes, they're trying to build implement all sorts of production ready features. They aren't out yet, but probably by December they mentioned that PyTorch will be production ready.
Okay. Couple of observations. One is that I think somebody earlier mentioned about earlier there was structured data. It is not there. I think what he's referring to is tabular.
Yeah, it is. It is there. You're right.
Yes.
So the vision is of course vision. Then the text is NLP. Tabular is what is called structure, and the collab is what was the collaborative
filtering. Collaborative filtering.
Yeah.
As regards the business model, I think somebody had asked Rachel, and she has mentioned that the software is being used in Fortune 500 companies also. Because see, I'm pretty. If it has to be a success in the real world, moving beyond a learning tool, I'm sure they're expecting that people will also learn to use the code. Not just the concepts. So I'm sure there is a business model which probably recognizes the fact that people will want to. Otherwise, what really happens is that whatever work we've done, let's say in the earlier course, we cannot really port the code part of it into our new learnings, because every challenge, even though it's coming into this one of these 4 categories, either vision, NLP, or structured or collaborative filtering, but most of the underlying concepts probably are the same, because they if you recollect, he had positioned the earlier course as a 3-line code. The starting lecture was a cats versus dog was a 3-line code. You just need to learn these 3 lines and you are done for life. So so let's hope. And because for us, really, when you talk to customers, you need to be talking of production ready code which has been tried and tested out. It becomes really difficult to keep chasing a moving target. What do the other guys think?
I think they get to it towards the later part of the lectures, and the users on the forums who found it useful, like who have actually gone ahead and made their own libraries derived from Fast.ai, like they would dive into the code of functions and all. And personally, I found that useful, like, but it takes a lot of time for me just to, decouple a single function. It would take an hour just because they use all of the cutting edge practices. Even in Python itself, you can always find new functions.
And actually, Sam had made a very relevant point when we were having the Slack discussion. He had asked whether Jeremy was a Perl programmer, and it actually turned out to be true. Jeremy was the head of the Perl development group because the variable naming and also. I think let's keep our fingers crossed and hope that at least the as we move ahead, it's more stable and more tuned for the long-term production usage.
But for now, TensorFlow is the gold standard for production, and hopefully
Yeah.
PyTorch will follow.
No, I have a feeling TensorFlow is essentially reinventing itself also, because they have realized, if you realize earlier, they had lazy execution. Now they moved into eager execution. So they are looking at some of the limitations which were there earlier, and which competition is good. It's good for all of us because we get to learn the best.
I think it's interesting to see that both of the libraries are sort of converging onto the same path, that PyTorch is bringing in production ready aspects, and TensorFlow, like you said, has made eager execution its default API in the upcoming release. So I think it'll be for the best of us anyways.
What I love about the course is that he literally picks out the latest contemporary research, and for example, the work that he's done on the Stanford Dawn set is amazing. Just with a few $40 an hour, $40 total cost, if you're able to beat giants, it literally puts up the world at notice.
For sure.
Yeah, so it's good. It's good.
Yeah, and they keep doing that. So since the last version of the course, now they've changed the 3 lines of code. Now it's fit one cycle, which is, again, they've implemented the one cycle learning policy, which was not implemented in 0.7 libraries. So they keep doing that all the time. So that's great. Yeah.
My only concern is, I think, because I don't know what is the size of the core group. Maybe besides Jeremy, there are 3 or 4 other people who are contributing. Because yesterday or day before, somebody had reported a 0 division error. In the learn function. So on the forums, it seems to be like a kind of a silly error, because if you realize, Jeremy has always been saying that even small data sets will do, because nowadays the real world problems are really in small data sets. So somebody was trying to compare license cards with PAN cards. PAN is the India income tax identity card, and he was getting a 0 division error, which actually I think it was one of the prediction classes was not getting any value, so it was the denominator was 0. So I think S. Cougar, who is helping Jeremy, has just replied on the forum saying that in the next version of the library, they will put in a check for the 0 division, which to me, I mean, from a software point of view, it's like a no-brainer. Whenever you have any division functions you put in the software, you need to make sure in your test cases that you're not dividing by 0. So maybe in a hurry to push things out, care is not being taken in the library. So
they had deadline of the course start, and they had to make work, I guess. But there's still a lot of pull requests on a GitHub repo, so they keep changing all the time, a lot of stuff. So I agree.
And PyTorch is more like, you can compare PyTorch with respect to Keras, because it is also, let's say, trying to make use easy. So instead of TensorFlow, it is like you can compare I think you can compare Fast.ai with respect to the Keras. And if you remember, in Keras also, everything breaks all the time because they are always changing the way they input the data or some functionality. So this was the problem with Keras also. And yeah, like
okay. Anyone has had a chance to look at the Microsoft libraries which they have recently open sourced? They have recently open sourced some machine learning libraries about a couple of months back. Because I really respect Microsoft in that sense. They are extremely tuned to what the market and what the production systems require, and they have an amazing amount of humility in terms of the way they approach. So I'm just hoping that with their recent takeover of GitHub, and they'll be able to come out with both libraries which are stable, as well as you can add on your cutting edge layers on top of the new developments on top of their libraries.
They actually had a few very interesting announcements in the PyTorch conference. Like they mentioned, they switched to PyTorch for their internal production environments.
Okay.
And they've actually committed that they'll have a fixed development team to contribute to PyTorch as well.
Oh, great.
So I think they're shifting to PyTorch internally, and they mentioned that their customers, they prefer PyTorch as well. So I think they're moving on to a PyTorch path, Microsoft.
Okay. That's nice to hear.
So regarding the format of the of our meetup, so what we did yesterday was we had like probably half of the time we had discussion of the lesson, like now, and then the half of that time we also took as a very short like mini presentation, like 5-minute presentations on certain topics. Maybe that would be also interesting to do that here. So like if anyone's interested to do like a short presentation, it doesn't have to be big. You don't even have to have slides for that. Say, for example, we're talking about feature importance. If someone wants to present how this works, show a couple lines of code and maybe some graphs, that would be nice.
Just a 2-3 minute talk.
Yeah. So that maybe we could try that for next time. If you want to present anything, just reach to us on the Slack, and we'll plan that in agenda. So we plan like half an hour for the lesson discussion and then half an hour for some presentation on some machine learning concepts. And yeah, so next lesson is lesson 5. We'll continue with that. And Christian attempted to create version 1 of the notebook. I think that was lesson 1. I'm not sure if anyone looked at that so far. I didn't have a chance to do it yet. And that's pretty much it for this week from me. Anything else from anyone?
Thank you for all your efforts, Michael. Really thanks everybody.
Yeah, thanks everyone. Let's meet next week. Thank you.
Thank you for joining, everyone.